Good day everyone, you are welcome to Science Explained. Today I want to have a look at chemistry, in which we are going to be dealing with mass volume calculation. What do I mean by this? The mass and the volume will be given in the question, or rather you might be given one while we are asked to find the other. But there's something that is very important. And what is that? You must have a balanced equation of reaction. If the equation is not balanced, then you can't get it right. So, and as well, the MV here means molar volume. Molar volume simply means the volume which 1 mole of any gas will occupy at STP. STP stands for standard temperature and pressure. Any gas, 1 mole of it will occupy 22.4 dm cube at STP. While these are the relative atomic masses of the constituent elements, that is, the elements involved in the chemical reaction. Let me pause the video while you give it a try. Now, the first step I'm going to take is this. Since I'm asked to calculate the volume of carbon 4 oxide. Yes, carbon 4 oxide is the same thing as carbon dioxide. The volume of carbon 4 oxide gas at STP liberated when 5 grams of zinc triiodocarbonate 4 is heated. That means I am given the grams of zinc triiodocarbonate 4 while I am asked to find the volume of carbon 4 oxide liberated. This is the equation. So this is the carbon 4 oxide gas. We are calculating its volume. Why this is this zinc carbonate used that is heated to produce this. So how do I start? Since mass is involved, I need to calculate the molar mass of zinc triiodocarbonate first. That's the first step. How do we calculate that? By adding the masses, atomic masses of the constituent elements. So, molar mass of zinc carbonate. That will be, zinc is 65, carbon is 12, oxygen is 16, but that will be multiplied by 3 because of these 3 here. Alright, what would that give us? Let's do the calculation. That gives 125 grams per mole of zinc carbonate. Okay, according to the reaction, one mole, this is 1 mole of zinc triiodocarbonate. 1 mole of zinc carbonate liberated 1 mole. This is 1 mole of carbon 4 oxide gas. 1 mole of CO2. Okay. And 1 mole of zinc triiodocarbonate is equivalent to 125 grams per mole. That's why we say 125 grams per mole. Okay, that means 125 grams of zinc carbonate will liberate 1 mole of CO2, and 1 mole of any gas occupies this volume. So that means it will liberate 22.4 dm cube CO2. Yes, according to this. Okay, what will 5 grams now liberate? Let's call that one X dm cube, since we don't know. So let's do cross multiplication. Let's cross multiply and find x. So what will be x from here? X will be 5 multiplied by 22.4 divided by 125. Let's see what that gives us. That gives 0.896 dm cube. So this is the volume of CO2 liberated by 5 grams when 5 grams of zinc carbonate is heated. That's the end of this. Let's have a look at another example question, which will not be mass volume, but it's going to be on another calculation. This is another question. This one has to do with gas mass, gas volume. In fact, it is based on volume of gases. Yes. Gas mass, gas volume, but this time around we are not given any mass. So that means it's based on volume of what? Gases. We are given 40 cm cube of nitrogen gas. It reacts with 60 cm cube of hydrogen gas to form ammonia gas. So the first thing you need to do is to write a balanced equation of reaction between nitrogen and hydrogen that will give you ammonia. All right. Alright, this is the balanced equation. This is ammonia, hydrogen, nitrogen. Okay. Now, that means, according to, in this case, you are asked to find the volume of unused gas, ammonia gas formed, and residual gases. So I'm going to explain each time. But before we can do anything, we need to recall the Lusak's law that says when gases react, they do so in volumes that bear simple numerical ratio to one another and to the product if gaseous. Meaning that this is 1 mole here. When you don't see any visible number, it means 1. That means this is 1 mole, 2, 3 moles for hydrogen, 2 moles for ammonia gas. So these moles now will be addressed as volumes. That means we are going to write in terms of volume. That will be 1 cm cube, 3 cm cube, 2 cm cube. Okay. But the information we are given here says that we have 40 cm cube of nitrogen gas. That means given. And we are given 60 cm cube of hydrogen gas. This for hydrogen, this for nitrogen. Okay, what do? You have to look for which of these will be used as a standard volume. How do I mean? It is obvious here that for nitrogen, 1 mole is equals to or equivalent to 40 cm cube. But for hydrogen, 3 moles equivalent to 60 cm cube. So definitely from here we can get what 1 mole of hydrogen will be. So that means 1 mole for hydrogen will be 60 divided by what? 3. This 3 will divide this. And that will be what? 20 cm cube. So definitely it is obvious now that 1 mole of hydrogen is 20 cm cube. 1 mole of nitrogen is 40 cm cube. So we have to pick which of these two will be set as standard, and that is the smaller one. Take note of that. You take the smaller volume. That means we will agree now that any gas here, 1 mole of it will be equivalent to 20 cm cube. So what will now happen? According to this, it means that out of nitrogen, which has 40, only 20 cm cube will be used. So used nitrogen is equal to 20 cm cube. Why is it 20? Because we have agreed that this is our standard. 1 mole of any gas now will have to be equivalent to 20 cm cube. We can't take 40. Because if we take 40 as 1 mole, hydrogen will not be able to take part in the reaction. Because we have 3 moles of hydrogen. And 3 times 40, 120. And we don't have up to 120 cm cube of hydrogen. We are given only what? 60. But if you use 1 mole to be 20 cm cube, that means the nitrogen will partake, hydrogen will partake. So that means out of 40 cm cube of nitrogen that we are given, only 20 is used. So unused nitrogen will be 40 minus 20, which is 20 cm cube. That means we have answered question A, because that is the unused one. The ammonia that is formed, B, ammonia will be equal to, we'll go and check the number of moles of ammonia. And how many? That is what? 2. And since 1 mole is equivalent to 20 cm cube has been set as standard, that will be that 2 times that 20, which is 40 cm cube. Residual gases. What do you mean by residual gases? Means the excess or the unused gas left plus the gas formed. That is what we mean by residual gases. And the unused gas is nitrogen, which is 20 cm cube, plus ammonia that is formed, which is also a gas, that is 40. That will give us what? 60 cm cube. And that is the end of the question. If you appreciate this teaching, please do not hesitate to subscribe to my channel for subsequent release of more videos on physics, chemistry, and mathematics. And also like the button and share. See you in the next video.